I would record this, so I'm going to record this. Day one. What is a sampling distribution? So let's look at this. I'm just going to sit out here and talk while you guys. All right. So it says, how did the Unit 5 test go? The first part of the Unit 5 test, we'll talk about that. Today we will be taking a sample proportion from a population. We'll use an average from the sample to estimate the average for the population. Guys, you've got to know when you're doing a sampling distribution. You cannot take and find always the entirety of a population, can you? Maybe the population is too big. So what we find is that if we dip in, think about it as trying to figure out every fish in the sea, the characteristics of every minnow in a pond. You can't, can you? You literally would have to drain the pond, pull them all out, look at them.
Lock down, lock down. Lock the doors, stay away from the windows.
Oh, they're doing it in the cafeteria.
Oh, that's right.
Lock down, lock down. Lock the doors, stay away from the windows.
You never know.
I was scared for a second. Not gonna lie.
We would normally close the blinds. Y'all practice.
Lock down, lock down. Lock the doors, stay away from the windows.
I started panicking for a little bit.
That one should be locked automatically.
Lock down, lock down. Lock the doors, stay away from the windows.
I don't know. It doesn't matter. It's just like.
No, I mean, I want to be safe, but I want to be not.
Lock down, lock down. Lock the doors, stay away from the windows.
The last place I'm gonna die.
All right, guys. I'm pretty sure this is.
Lock down, lock down. Lock the doors, stay away from the windows. Lock down, lock down. Lock the doors, stay away from the windows.
All right, in the event of a real lockdown, guys. In the event of a real lockdown, we would turn off the lights.
Lock down, lock down. Lock the doors, stay away from the windows.
Guys, we're going to treat this like it's real because I don't know otherwise. We're going to spread out. Y'all need to spread out so if somebody would come in.
Lock down, lock.
All right, hang on.
Everyone's social distance.
Stay away from that because it's not covered. There are horses in the wild. You duck down in between the tables, right? Down between the tables. Okay. All right. Yes. I'm like, just huddle up under. Nobody seems to be running. All right. You would try to do things like get backpack or something to cover yourself with book, whatever, your notebook. You have my permission to use your stats notebook if you need to for that, in case of a real lockdown. And you would want to arm yourself with something heavy if you can to throw at somebody if they were to come in. I'm not kidding. And if somebody were to come in, the first thing I'd want you to do if we thought this was a real lockdown is I would have you guys helping me move.
Lock down, lock down. Lock the doors, stay away from the windows.
But
So it isn't.
we would still trip them up, I think so. I think so, but I don't know for sure.
Lock down, lock
Do you
down.
know about this?
Lock the doors, stay away from the windows.
The one last year?
We would stay very quiet.
There was a-
Austin High School student and faculty. We found it was somebody pushed the lockdown by accident, it's disregard. You can now be released from the lockdown. This is Mr. Fry, you can be released from lockdown.
Okay, now we're good.
Thank
See, I
you.
didn't remember this. So we were under a real lockdown, guys. So just be aware. All right, so if somebody will turn the lights on, please, we can get going. Back to what we were doing. All right, so aren't we excited about this? Okay, guys, so here we go. How did the Unit 5 test go? We're going to take a sample from a population. So we've just said we need to take a sample. We're going to use the average from the sample, right? To estimate the average for the population. That's what we find out. If we take a big enough sample, we can actually take the characteristics of the sample as the characteristics of the population. But there are only certain times we can actually do that. So it says, number one, it says make a dot plot of the distribution. So we got 4 people who took the Unit 5 test. We got a 60, a 70, an 80, and a 90, don't we? All right. So it says make a dot plot of the population distribution. This is our population, isn't it? How do I know this is my population? It represents what? Everybody who took the test. So that is a population. So how do we make a dot plot? We put first thing is we give it a name. And guys, if you don't give it a name, that will count off. That can dunk you from an E to a P really quickly. They do actually count whether or not you label things. So what are my test score? What numbers do I need to put down here?
6, 7, 8, 9.
50 to 100 probably.
I should go 10 to 100.
And if we're going to do a dot plot, we're going to put 1 dot what? For each of the population things, okay? So it says take a sample of any 2 of the scores. Give me 2 scores, Walker.
80 and 90.
80 and 90. Okay. So now it says find the mean. So what is my mean going to be? And I'm not going to use this mu anymore for mean. Do you know what I'm going to use since it's a sample? X bar. So how do I find the mean? 80 plus 90 divided by 2. 170 divided by 2 is what? 85. Now it says find all possible samples of size 2. So this is a case of where we would take every possible combination. So what are all my combinations? 60, 70, 60, 80, 60, 90, right? And then what? 70, 80, 70, 90, and then the last one is 80, 90. Okay. So let's go ahead and find the mean for every one of those. So X bar here would be what, 65? X bar here would be 70. For 60 and 90, it would be what, 75? 70 and 80 would be 75. 70 and 90 would be 80. And 80 and 90 we said would be 85. Now, it says make a dot plot of all the means we found there. So let's take a dot plot. So our dot plot is not going to be means anymore. It's not going to be test scores, is it? What did we actually find in each one of these? The sample mean, right? All right, so this title of this one is sample means. This is a distribution. This is a sample distribution. This, guys, is not. This is a population distribution. Do you get it? This is my population distribution. This would be a sample distribution of the sample means, okay? So what did we have? We had everywhere from 65 to 85, didn't we? So 60, 65, 75, 80, 85, 90. Okay, so we had one at 65, one at 70, two at 75, one at 80, and one at 85. Is this what my sampling distribution looks like?
No.
Oh.
Kinda.
That's all the sample means, isn't it?
That looks much more normal.
It does. All of a sudden, we've gone from a uniform distribution to suddenly we have a normal distribution, don't we?
Yeah.
Oh, do you see the power of sampling?
Power.
Power of sampling is it normalizes stuff. Now, where did we find our mean? Where did we find our middle for our sampling distribution? Right at 75, didn't we? That's where the peak is. Now, I want you to take the mean of those test scores. We have one at 60, one at 70, one at 80, and one at 90, didn't we? How do I find the average for the population? Yep, 60 plus 70 plus 80 plus what? Divided by,
4.
what do we get?
75.
Huh. Do you suppose it's a coincidence that the peak of the sampling distribution is the same as for the means of the samples that we took, is the same as the mean of the population? Now, they would have to be the same. Now, is this always going to happen?
No.
It should be very, very close if we take enough samples. And that's the thing. Now, why did we get it perfectly here, but we only took a certain number? We took a small sample, didn't we? But we took every single possible combination, right? So we're not going to be able to do that every time. So what we need to do is we're going to be looking at what is a big enough sample to find this to match this. So we'll finish this up for lunch. Is that for them to leave or for us to go? Okay. All right, I'm recording again. Let's go. So we made a dot plot and we looked at this. Now, what we're looking at is parameter versus statistic. Please remember a couple of things. When we talk about a parameter, we're using Greek letters, right? Population, parameter. P and P go together, right? So a parameter is a population statistic. Okay, we use Greek letters. All right, so when we're using Greek letters, we know this is the mean. This is probability. This is standard deviation. And that is our number. Okay? Or size. Now, probability slash proportion. You see sometimes proportion. Okay? So those are our Greek letters. We know what each one of those means. Now, when we go to a statistic is what we use with a sample. Parameters with population, a statistic is to sample. You notice how easy those are to remember. Statistic goes with sample. Parameter goes with population. These we use regular English lowercase letters. X bar, P hat. Notice P and P hat. The little thing on the top is what we call a hat. So this is our mean. This is our proportion. This is our standard deviation. And really this should be S sub x. And this is our what? Sample size? Right? This is our sample size. All right, P goes with P. Parameter goes with population. S goes with S. Stats come from a sample. All right? So you need to know those samples. You need to know those things. If somebody asks you for a parameter, and I've seen that. That was a mistake I made the first year I taught, was I didn't really tell my kids what a parameter was. And we got to the practice exam, and they were all like, Ms. Duffy, what is a parameter? And I went, you're kidding, right? And they were like, no, we don't know what that is. And I'm like, all right. It's a statistic that goes with the population instead. And they were like, oh, well, that would have been helpful. So you all know what a parameter is. If the problem is asking you for parameters, it's asking you for the mean, the standard deviation, the proportion and the sample size for, well, the size, not sample size, for the population. And if it wants something for the sample, it will ask you for a statistic. Here's my chart. Oh, there it is. Here it is. Oh, it's at the bottom. How bizarre. Okay, it's in a different place than yours was. All right. So here is your chart that summarizes everything. X bar is X bar. It should be above X bar. Mu is, of course, mean. Sigma, that little standard deviation thing is sigma. Standard deviation is S, usually S sub x, but it could be S sub y, S sub z, whatever. It's just S. That's what's on your calculator, right? Notice you have sigma and S on your calculator. Proportion, P. Rho is for proportion, and P hat is for your sample. And then little n is for your sample, and big N is for your population. Does everybody get that? The difference between little n and big N? We're good. All right. It says the value of parameter is usually not known. Why is the parameter usually not known? It's really hard to do a population. Think about it. Back to the minnows in the pond question. You can't pull all the minnows out and check every one of them. If we want to know the average length of a minnow in the pond, we can't pull them all out and measure them. How? Name some reasons why examining the entire population is not possible, because the population is what? Too large? Think about that minnow thing.
Takes long.
Too long. Yep. Takes too long.
Just hard to find.
Yeah, and takes a lot of resources, right? How about this one? Not possible. What if I want to find the average time that, the average life expectancy of a woman?
All women.
Yeah, how are you going to do that one? You can't. So sometimes it's just not possible. Okay? Takes too long, too many resources. It's not feasible. Can't be, happen, cannot happen. All right. All right, so please do not fear. A way to save the day is here. You guys have this? You don't have these two? What? I skipped something. Where is my... So now we go on to never fear. A way to save the day is here. All right, so value statistics can be directly calculated from the sample. And we're going to use statistics to estimate parameters. So the first thing, though, is you need to be able to identify what's the population, what's the sample, what's the parameter, what's the statistic. So this should be a little bit of a review for you because you've done this before. So look at first one. It says identify the population, parameter, sample, and statistics. So what is the population in this first one?
623.
No.
U.S. adults.
All U.S. adults, right?
You group.
So U.S. adults. The sample, however, is what?
Say it, DJ. 623.
623 adults, right?
U.S. adults.
Yes. All right, so parameter. What is my parameter?
All U.S. adults.
No, that would be the population. What is the parameter? Is the thing we're measuring?
Whether or not they believe in aliens.
Yes, whether or not they believe in
Believe in aliens.
aliens. Parameter is the proportion, right? Who
Believe in aliens.
believe in aliens.
So it's 219.
Statistic is what?
319.
Out of,
623.
yes, remember it's a proportion.
What do you think, Ms. Douglas?
So this would be p hat, and we could leave it that way. What do I think? Are there aliens? I think it's a really big universe.
I think you're on patch or something.
There's no way there's not something.
I think the probability of there being life on some other planet somewhere else is huge. The probability of them finding us and having faster than light technology to get to us, that one I'm a little iffy on.
Star Wars.
And Star Wars? Is it?
That was a long time ago. I think of
Oh,
I think every like superhero. I think it's all real. I think it's just a bunch of movies.
Now,
It's just videos from.
B, do B. Find your population. Let's see how you guys can do. Talk it out at your table. Population sample. Parameter. Statistic.
All written
P equals and then P hat equals. Or it might not be P this time. Maybe we better be careful here.
in that, right? You're sure.
All right, be very specific when you're doing the population. Make sure you pay attention to all the hints they give you. Ah, there you go.
Portion to contain.
Did you include this? Did you include this in your population description?
Oh.
See what I mean about being specific?
All life in water bottles in the plant on Monday.
Yeah, you can practically plagiarize it right out. This is the only class where we encourage you to plagiarize straight out of the question prompt.
Yet I still get wrong.
So what do we think for parameter? Parameter is the proportion of balls to bottles.
Now, is it proportion though? What word tells you what the parameter would be? This word right here.
Average.
So instead of the true proportion, we'd say the true what?
Average.
What's the word we use for average? Mean. The true mean, right? The true mean what?
Ounces. True mean in ounces of the bottle of
Yeah. True mean ounces of
Drink,
in a
bottle,
bottle.
true mean of ounces of drink.
So this is all
Of a bottle.
vitamin water bottles filled
Not in
at the plant on Monday. What is, and the parameter would be the true mean, which is mu, ounces of vitamin water. Don't make it a proportion, it's a mean. What is the average? What is the mean? There you go.
So that's just
Mu, X bar, right? Yeah, in this case it'd be, so if it's mu, it's X bar. So this would be our statistic, 19.7 ounces.
Do we have to put the X bar?
Yes. Please get used to it.
It's so tedious.
What was the sample?
65 bottles.
Yep, the 65 inspected bottles. We've already covered Monday. All right. So does anybody have any questions about the difference between a population and a parameter, a sample and a statistic, and how we do that? So remember, for your parameter, you're trying to tell, is it a proportion or is it a mean? So that in your statistic, you know whether or not you're talking about p hat or x bar. Okay? All right. Let's talk about sampling variability. Sampling variability. Recall from day one. Shouldn't be that hard. It's often impossible or unreasonable to examine the entire population. Thus, we use statistics, which are taken from a what?
sample.
Thank you. From a sample
Good job.
to make inferences. Inference is the word you need to know about an unknown parameter. So sample helps us infer stuff about a parameter. That's the way it kind of works. If we take a sample of 50 adults chosen at random, measure their IQs, you could find their average IQ. And this should be X sub 1 bar, not below, above. I don't know why they put it below. It says, now take another sample of 50 different adults, chosen at random, measure their IQs. Then take their average, X bar 2. What do you notice? What would you think about both samples? Would the samples be the same? Would the IQ be the same? It might not even be similar. It really depends on which 50 you pick from the population, right? But over time, eventually we will pick enough of them that we can take the average of the samples we picked. The average of the samples we picked, it should look like the population. See what I'm saying? If we dip into that pond and measure some fish here, and then we dip another and measure some more fish, and we put them back. We dip another, measure some more fish. Dip another, measure some more fish. We're taking the average of this sample, 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 and then we're taking them all. We're looking at the distribution of that. Okay? Notice that the distribution is an average of the statistic that we're pulling from the overall population. Do you get that? A lot of people forget and don't think about what a sample distribution is. It is not we took a sample and found this length. We took a sample and found this length. It is an average, taking all of those together and looking at what the entire distribution of those look like. If we take enough of them, it should look like a normal curve, and the population parameter should be right in the middle. Get it? So we've got a population, and this is the thing you've got to remember, is we've got a population here. From that population, we're going to pull a bunch of different samples. So sample 1, sample 2, sample 3, and so on. Get it? Each one of those samples, we're going to take a statistic from, aren't we? Now remember, that statistic could be either p hat or x bar. Once we take all of those and we do a distribution, this is a sample distribution, okay? The distribution is not the actual parameter, it's the statistic. If we do enough of those, looks like this, and whatever this is right here, should look like the population parameter. So does everybody understand how we take a sampling, what the function is in taking a sampling distribution is? Okay? There's a method to it. We pull samples, we figure out our statistic, and then we take all of those and make a distribution out of them and then look at that distribution. All right. So here we go. It says this basic idea illustrates the idea of sampling variability. Okay? Sampling variability says that any one sample is not going to look like the rest of the samples, is it? But overall, the distribution will end up looking like, we'll point out our population parameter. Is there anything I said there that nobody understands? Sampling variability means every sample that you dip. Think about dipping a bucket in to get minnows. This set of minnows is going to look different than this set. It's going to look different from this set. It's going to look different from this set. That's sampling variability. Every sample, individual samples look different. But overall, the distribution is going to lead us to the population parameter. All right. So generally, we use the notion of sampling variability in the following way. Here are the biggies that you got to take from this. Take a large number of, hang on. Come on. Take a large number of samples from the same population. I can't take a couple samples from this population and a couple samples from that population. If we're going to take samples and do a sampling distribution, it's got to be the same population. We can't dip from one pond and then go over here and dip from that pond and then dip from a third pond and expect that it goes back to the population, does it? No. All right, we calculate a statistic. That would be either the sample mean or the sample proportion. That'd be your x bar or your p hat for each sample. Notice what it says, for each sample. And then we make a graph of the distribution of the sample statistic. Are you seeing what I'm doing? All of these make this. Get it? And then finally, we examine the distribution for the shape, center, and spread, as well as outliers or unusual features. Because we need for this thing to be normal, don't we? Because if it's normal, then we know our population parameter, whatever it is going to be right smack in the middle, isn't it? Okay. When we make this graph, we get a distribution of a sample statistic. So a distribution of sample statistics is a distribution of sample data. An actual sampling distribution in all its glory is the what? All possible samples of the same size from the same population. So a true sampling distribution is like the one we did at the very beginning where we did every possible combination, isn't it? So is it possible to do a true sampling distribution most of the time? No. Because if you did a true sampling distribution, you'd have every possible combo. Well, then you've looked at the entire population, haven't you? Go back to females. You're going to take every single female and look at them. You already have the population. You usually don't have access to the population, so you don't have access to every possible combo, do you? So what we're looking at is distributions of sample data. Please know the difference between these two. We look at this, typically this is what we use, and this is the perfect world sample, right? Do you get what I mean when I say perfect world? In a perfect world, we would be able to check every possible combo, wouldn't we? So this is some samples, and we're going to say enough. And this is all samples. So does everybody understand the difference between a distribution of samples and a sampling distribution? I have seen this question come up over and over again on the test. Is something a sampling distribution or is it a distribution of samples? Sampling distribution is all possible samples. All right, so what's the population distribution? Gives the value for all individuals in the population. This is like the number one we did in our starting unit activity. We're not taking samples from it. This is just the distribution of the population. That's y'all. All right, guys, listen. I want you to do homework 1. We didn't quite finish. We'll finish up 2 next time. So you have homework 1 this time. And you need to study for your test, work on studying for your test. Next time when we get together, we will do I will pull together a couple of good multiple choice questions for you. And I will pull together a free response for you. And then we're going to finish up stats, day, sampling distributions for days 3, 4, and 5, okay? So next time's going to be a big haul on notes, but